Hello students, how are you? I hope all of you are quite well. So in continuation with our series where I am placing good important expected problems for IIT Advanced 2022, here I am placing one more question based on the chapter of solution on the topic of Raoult's law. So here comes the question in front of you. Here in this particular problem, two liquids A and B are being provided to you which tend to make a ideal solution at 300 Kelvin. And this solution, for this solution, the Raoult's law is being shown in the graphical form. So the graphical representation of Raoult's law is being given to you in front of you. So the vapor pressure of pure A is 10 torr and that of this is B is 30 torr. And they have given you a mole fraction. At some composition, the mole fraction of XA is 0.6. And at this point, they are asking what is the total pressure at point L corresponding to 18 torr, and they are asking mole fraction of A and B in the vapor state at point M. And lastly, they are asking something in regard to the composition of the A in the last droplet of solution when the solution is gradually, the pressure around the solution is gradually decreased isothermally. And for that, they have given a new mole fraction XA dash. So leaving aside the last part, first let us see what this graphical representation, what are the things to be taken care of while evaluating this graph. So firstly, what you have to remember is, if you know well, otherwise just add it into your knowledge bank, that this particular line is representing the liquid phase composition, whereas this curved line is showing the vapor phase composition. Later in this video, I'll let you know why the first line, which is a straight line, shows the liquid phase composition and why the curved line is showing the vapor phase composition in a while. Now, what else you have to also understand is that this XA is the, now make it a point, you are being given a situation where you have a liquid. Let's say this is a piston attached to it and there is a liquid here. And in this liquid, that XA and XB is being given. The XA composition is 0.6, that the number of moles of A is something here in the solution, and NB is the number of moles of B in this particular solution. If XA is 0.6 and this is 0.4, so this is 0.4, this is very clear. Now what you also have to identify, what you have to check it at this point is that while you have this composition with you, what shall be the total pressure above this particular solution being shown by the vapors of this A and B. First statement is that, and when this liquid comes in the form of vapor, at this point, what is the vapor phase composition? The vapor phase composition is being depicted. This composition is showing the liquid phase composition. Above this liquid phase, what is the vapor phase composition is this one, or rather I would say, okay, let me first do it and then explain it to you. So what we are saying is that first you have to understand P total is equal to PA plus PB, and applying the Raoult's law, what PA shows, PA is partial. Now if I have this liquid with me, and this liquid is consisting of A and B. So what is the pressure being shown by A and B? The partial pressure of A, according to Raoult's law, would be P naught A into XA. Now what is very important here is, this is the mole fraction, this is the most important point, mole fraction of A in liquid state in the solution according to Raoult's law. This is what is being shown by the Raoult's law. Similarly, if I would say PB is equal to P naught B XB, and what is this? This is the mole fraction of B in the liquid state. Okay, so corresponding to this, we can evaluate the P total. So P total happens to come out to be P naught A XA plus P naught B XB, and this happens to be what? So it was 10 into 0.6 plus it was 30 into 0.4. So this comes out to be 18 torr. So what we are saying is that at this point of time, at this juncture, we have at this point the total pressure, the P total is 18 torr. The pressure being shown or shown by the liquid A and B at 300 Kelvin is 18 torr. Now the fellow is asking that at 18 torr what shall be the vapor phase composition, which is being depicted by this. For that we have to bring in the topic of Dalton's law. What basically is Dalton law says, unlike the Raoult's law, Dalton law also would tell me the partial pressure of A. If I would say this is the liquid and these are the vapors. So here you have a liquid and this is the vapor. Now Dalton law is applicable on the vapors. We presume vapors to be behaving like gases, ideal gas. So that is why we are applying the Dalton's law. What Dalton's law says? Dalton's law says that P total into YA. Now what is YA? This is the mole fraction of A in vapor state. This you have to understand. And in the solution, while evaluating PA, while evaluating partial vapor pressure of A, from the values of mole fraction of A and B in solution, we have to apply the Raoult's law. What was that? P naught A XA. This is in accordance with Raoult's law. So here you have to be little vigilant about. So what we can say now is PA is equal to P total into YA, which can also be written as P naught A XA. So from this data, I can evaluate one thing, that YA is how much? What is YA? Mole fraction of A in the vapor state at a pressure of 18 torr. So it is 10 into 0.6 divided by 18. So this comes out to be 1 by 3. So that is 0.33. So YA is 0.33. So YB can be written as 1 minus 0.33, that is 0.67. So the what we have happen to get here is that what we are suggesting here, or what we got here is that if I would write it here, that this is 0.33 and this is 0.67. This is what we got, that when the pressure was 18 torr at this situation, what is the mole fraction in the vapor state? The A is having 0.33 and B is having 0.67. Is it okay? So this is what one thing you should know about it. Now first let us see the options available. So the total pressure at the point L is 18 torr. This is perfectly right. Mole fraction of A in the vapor state at point M at this point is less than 0.6. No, these are confusing questions. The statement is written in a little tricky way. Mole fraction of A in the vapor state at M is less than 0.67. What was YA we got? YA was 0.33 and YB was 0.67. So it is less than, so this means it's a correct one. It is 0.33. Vapor phase of B in the vapor state at M is greater than 0.33. YB definitely it is greater than 0.33. So both statement in a way are correct. Now coming on to the last part, when the pressure of the solution is gradually decreased isothermally. Now this is a little tricky, which we have to now do it very carefully. Now what the point is, that if I have this liquid with me, so first you have to understand this fact, that if I would show the graphical representation once again to you like this, so what basically we are doing, we are somewhere here at XA 0.6 and XB 0.4. Corresponding to this, we found that YA was 0.33 and YB was, till this point we are clear with the things. Now what they are bringing in a, that basically, if you have to understand here, the pressure P naught A was 10, here P naught B was 30. Now what they are saying is, if I am moving from this line from here downward, what basically I am doing, I am decreasing the pressure. When you are decreasing the pressure, basically here was the liquid which was producing a pressure of 18 torr, and if you would decrease the pressure by moving the piston up, if the piston is moved up, there was a liquid here, what would happen? A vapor would come out. A vapors keep coming out. So there would be a situation if I keep on decreasing the pressure by keeping the piston up, what would happen? The liquid keep on changing into vapors, and there would be a situation when entire of this liquid would change into vapors, and there could be a situation when last droplet is left. If I just have darkened this one drop as a last droplet, what would be the situation? We are saying to begin with, XA was, if I would write it once again here, XA was 0.6 and XB was 0.4. Now if I keep on decreasing, let me show it here once again to you. So if I keep on decreasing the pressure, I would reach this point from L to N, let's say. At this point, what I am going to say here is that entire of liquid has been changed into vapors, because when you are, or let me write it in another way. Let's take an example. Let's say A liquid changes to A vapor, and there is an corresponding to this at t equal to 0. This is A mole, this is dash T1. Let's say this is A minus X and this is X. And at this point, there is a pressure, some pressure is being developed, which is equal to X RT by V. And this is a equilibrium pressure. Let's say the equilibrium at this point, equilibrium has been achieved. Now if I would disturb this equilibrium, the equilibrium by decreasing its pressure, this equilibrium would move forward, because when you disturb the equilibrium by changing its pressure, that means you have increased the volume. Let's say if you have increased the volume, pressure has decreased. Now to get up with the same pressure, this equilibrium has to move forward, and if it move forward, so more of the liquid would change into vapor. This is the viewpoint from the equilibrium point of view. So what we are, let me come back to the topic. So what I'm trying to say here is, which you always have to remember, a simple trick or simple point. Please be attentive at this moment of time. If you are able to get this in first go, you would feel happy. So basically, initially the entire liquid, if I would say initially what had been the situation, the liquid XA is 0.64 and XB is 0.4, and you started decreasing the pressure by increasing the volume, let's say. And what would happen when you increase the volume? The liquid started changing into vapor, and there would be a situation when entire of liquid has changed into vapor and last droplet is left. Now this last droplet, this entire of this has been changed into vapors. So this is the vapors. So what I would say is that I am trying to know what is the endeavor, what is the viewpoint. We are wanting to know XA dash and XB dash. This we wanted to know. But at this moment, when last droplet I have with me at this juncture, the YA dash and YB dash is exactly the same as 0.6 and 0.4. It has exactly the same as 0.6 and 0.4. So this is what you have to remember, that this XA XB, because the entire of the liquid has changed into vapors, the last droplet would have a composition this much. This is the thing which we wanted to know. This is the question which is being asked in the D option. And corresponding to this, the entire liquid has changed into vapors. So what had been the starting composition or starting mole fraction of A and B in liquid now would be the vapor phase composition at that point corresponding to last droplet. So this is the viewpoint which you always have to remember. Now going forward, what we wanted to know is XA dash and XB dash. Now how can we go for that? We simply have wrote that the P total had been P naught A XA plus P naught B XB. We have to do a bit of mathematics here. So P total can also be written as XA plus P naught B 1 minus XA. So on opening it out, I would get P naught A XA plus P naught B minus P naught B XA. And from here, if I would write one thing, so I would get P naught A minus P naught B XA plus P naught B. Now if you would see into this viewpoint, that if you would draw a line between P total and XA, you would get a straight line. That is why the liquid phase composition line had been, the pressure line has been a straight line. So one statement we got here is a important statement. Now the another thing which now we would want to place it here is this thing, that this we got. Now what shall be the P total according to Dalton's law is this, and P naught A into XA dash. Here I am interested to know the new mole fraction corresponding to YA dash. Now what we are saying is this YA dash, if I would write, is exactly the same as XA, which had been 0.6. This is what I am trying to say it time and again. Let me write it once again for you. This XA, which was the starting one, now would be the YA dash and YB dash. This is what is very important. So I can say YA dash is equal to P naught A into XA dash upon P total. So P total we just have wrote is P naught A minus P naught B XA dash plus P naught B. This is from the last statement. This is the general statement I wrote, and if it is at XA dash XB dash, all of these would become dash. Is it okay? Because we are saying at that point. So from here what we can get here is this was 0.6, YA dash is 0.6, and this had been 10. XA dash we want to know out, and this becomes 10 minus 30 XA dash plus P naught B. P naught B was 30. So if we would solve this out, what shall we get? So this would become 20 minus 20. So this becomes minus 12 XA minus 18, 3, 6, 18, and this is 10 XA dash. So this comes out to be, sorry, this was plus 30, this is plus, so it becomes 18 is equal to 22 XA dash. So this comes out to be 9 by 11 XA dash. So it seems like correct, and XB dash would be 1 minus 9 by 11. So this is the answer we got. So this shall be, so this is 2 by 11. So XA dash they are asking. I think we got the answer right. What statement they have wrote? Let me check. So the mole fraction of A in the last droplet of solution XA dash is 9 by 11. So this seems like a correct answer. So it means that A, B, C and D, all the 4 statements written in this particular question is correct one. So let me once again state it very categorical here that in this particular question the D option was little tricky. In the D option, what is the viewpoint? That when the pressure is slowly decreased, the liquid keep on changing into vapor. By the time the last droplet of liquid is left, the last droplet of liquid is left, we want to find out its composition or its mole fraction in the liquid state. But at that point the vapor phase composition shall then be exactly nearly the same as the starting composition of A and B in the liquid state. This is the viewpoint which you always have to keep it in mind. And last year also, or last to last year somewhere, if you could check the playlist, this particular discussion has been done in more detail. If you want to see it, you can refer to this particular video session of mine in the DCD booster series of 2021. DCD booster series of session 2021. So this can be a important question which may come from the chapter of solution. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.